So in the first video, what I did is I created an equation that related the volume and the surface area, which I think would be less steps than what I'm about to do, but we're about to find out. So if you guys did this and you are fixated on these guys and you're like, oh, you know, I got my two equations, I got my volume equation and my surface area equation. You take the derivative of the volume equation with respect to t, you get dv over dt equals 3x squared dx over dt. And then you take the derivative of, actually we'll keep it blue, of the surface area. That would be dsa over dt equals 12x dx over dt. And so if you just took the derivative of those and you're thinking, oh, you know what, I really need this guy, this is what I'm trying to look for, then you're probably thinking, then I need to know what x is and what dx over dt is. And so is there a possible way? Is there a way to find the x and the dx dt? The answer is yes, absolutely, because we have this down here. We know that 54 equals 6x squared. So over here, I'm going to write 54 equals 6x squared. I'll divide both sides by 6. I get 9 equals x squared. And then I square root both sides. I get x equals plus or minus 3. That's because I could plug a positive 3 into this x right here and get 9, or I could plug in a negative 3 to this x to get 9. So that means I can take 3 or negative 3 and plug it into this. Man, I wonder which one that is. Is it going to be 3 or is it going to be negative 3? Let's think about it. Because only one of them should make sense for this problem. Does a 3 make sense, or does a negative 3 make sense for x? What does x represent? X represents one of the sides of our cube. And so having a side of length negative 3 actually does not make sense. And so I don't need to have the negative in there. All right, cool. It looks like we're closer to finding what dsa over dt is, which we decided at the beginning was our main goal. But we need to know what dx dt is. Dang it. So we have two variables. We have this variable and this variable. If we have two variables, we can't solve it. Maybe that's what this guy is for right here that I found. Good thing I got all derivative happy and just took the derivative of both of those guys. It looks like it is. It's possible because we know what dv over dt is. It's negative 10. We also know what x is, so we could plug in 9 right here. Now I can find dx dt. Ooh, that's cool. So 9 squared is 81, and then 81 times 3 is 243. So negative 10 equals 243 dx dt. That means dx dt equals negative 10 divided by 243. So to find dsa over dt, we just have to multiply 12 by 3 and then multiply that result times negative 10 over 243. 12 times 3 is 36. 36 times 10 is going to be 360. And so I get 360, negative 360, over 243 equals dsa over dt. Now, if you left it like this, just said meters squared per hour, because we know it's talking about surface area, that would be meters squared. Leave it like this, you would be good. You would be good. You wouldn't have to simplify it if you didn't want to, but just for answer's sake, so you guys can make sure you have the right answer, I'm going to go ahead and simplify it just in case you did. And if you left it like this, you're right, but let me give you guys simplified versions as well. Now, since 2 plus 4 plus 3 is 9, I know that the 243 is divisible by 3. So I'm going to divide the top and bottom by 3. And let's see what we get. We get negative 120 over 81. And then it looks like I can probably divide that by 3 again. Yes, I can. So I get negative, that would be 40. Divide the bottom by 3, that would be 27. And then I believe we are finished simplifying. So meters squared per hour. Actually, on the calculus AP exam, any one of these answers would work, just as long as you have the correct units on them as well. One more note about what I did here. Whenever you guys are solving a related rates equation, do not plug in values like -10, 54, or 3. Do not plug in values before you take derivatives. The only time you can plug in values before you take derivatives is if that value is constant. Within the context of your problem, is that value changing? If it's not changing, then go ahead and plug it in. But if it is changing, don't plug it in. In our context, x is changing because x is the side of a cube that is decreasing. We know from the context of the problem.